Yes, ma'am.
Who? Please name yourself.
Ma'am, Faiza Fatima.
Okay, Kaiser, thank you. Now, today we'll be taking up motions of the earth. Okay? Last time I had sent you the question answers of the diversity, prejudice, discrimination, and inequality. And
Yes, ma'am.
you are supposed to, so please go through it. Then we have also finished the question answers of the first farmers and herders.
Good morning,
And
ma'am.
then today I took, I'll be sending you the exercise 5 so you can do the question answers. And today between 10:50 to 11:30, you can send me your history copies for correction. Please, if your work is incomplete, you can send it on another next Tuesday, but make sure you start sending them. Otherwise, the correction won't be possible. Okay. Now we come on to motions. It is a new chapter where they tell you that it was Nicolas Copernicus. He was the Polish astronomer who first told in the 16th century that it is the earth which is revolving around the sun, not the other way around. Earlier, people used to think that earth was at one place, static, and it was the other heavenly bodies which were moving around. But that was not the case, okay? It was actually the earth which was moving around the sun in an elliptical path called orbit. So as we know that motions of the earth are of two types. One is the spinning on its axis. Okay, axis is the imaginary line drawn from North Pole to the South Pole. Okay, now the Earth's axis, as it spins, Earth completes the first motion that is called rotation. That means it spins on its axis and completes one rotation. It's called rotation. When the Earth spins on its axis, the Earth spins from west to east. Okay, in an anti-clockwise it spins. Okay, then the other motion is revolution. Now, revolution is the motion around the earth to revolve around in 365 and 1/4 day. So that is called revolution. Now, rotation, it causes day and night. Why? Because one full rotation completes in 24 hours. Okay. So once the 24 hours are complete, we call it one Earth day. Okay. Now the speed of rotation is 24 hours and it appears as if it is maximum at the equator. Why? Because the equator appears to be bulging and the speed decreases at the poles. Why? Because the distance to rotate is lesser at the poles. Clear? Now, effects of rotation would be they cause the centrifugal force. That means it causes a motion, a strong motion, because the earth appears to be bulging at the equator. Then also, as the earth is rotating, it is causing the wind currents to move. The wind, the atmosphere surrounding the earth, as the wind blows, it gets deflected because the earth is spinning. Okay, and same goes with the ocean currents. The ocean water, it deflects because of the fast moving earth, it changes its flow. Current doesn't mean the electric current that you get, the jhatka. No. Water current is the flow of water is called the current. Okay. Then it causes day and night. Now, rotation, once it completes in 24 hours, that is why we say if you see your clock, it is 12 hours clock and twice you see the same time in one day. That means if right now it is 10 o'clock in the morning, then you will have 10 o'clock in the evening also. So it takes 24 hours. Okay. Now these 24 hours are divided. Half is day and the other half is night. So that is the effect of rotation. It causes day and night. Then now we talk of circle of illumination. A circle of illumination very clearly tells you. Just a second, children. I will try to show you. Am I visible? Is the outer thing visible? Is the blackboard visible to you?
Yes, ma'am.
I'll show you. Now, if this is the earth, this is the earth. This imaginary line that we have drawn is the axis. Okay. Now, circle of illumination means if we imagine this to be sun and the rays are falling on earth. Now, the portion which gets the light, this portion here, this is the illuminated side, and this other side is the darker side. That means the picture that you see on the right hand side will have day, on the left hand side you will have night. And as the earth spins, in 24 hours, it completes one rotation. And thus, if this side is having day right now, the other is having night. As the earth rotates, each side gets a chance to have a day and night. Can you see the picture here? Can you see the sun?
Yes,
So
ma'am.
now I will quickly read it out to you how it happens. Keep looking at the picture. Now the sun is the ultimate source of heat and light for earth. We all know that. Due to the spherical shape of the earth, only half of it gets light from the sun at a time. See, you can see that green line which I have drawn here. Only that half can get the light. The remaining half remains in darkness. Okay. Now the portion facing the sun experiences day, while the other half away from the sun experiences night. The circle that divides the day from the night on the globe is called the circle of illumination. So you can see that green line from this the front side as well as at the back side, as well from behind the earth. That portion is facing the sun. So this particular sun side is the circle of illumination. The other side, this side is the darker side. This side you see, this whole part of the earth from front and from the other behind, that portion remains in the darkness. The circle of illumination is an imaginary line which separates the lighted part from the dark one. So, circle of illumination is basically that imaginary line where the sun's rays reach the earth. Since it is spherical in shape, only half of it could be illuminated at each time. And as it rotates, gradually the circle of illumination turns. That is why in the morning, early morning, we have 4 o'clock the sunrise. That means we are just at the side of the earth. The sun ray first strikes the earth. Then gradually at 12 noon, we are able to get the experience of a midday sun. And then by 6 or 7 in the evening, we get the dusk. That means the other side. So the earth keeps on rotating, and that rotation causes day and night. And the part which faces the sun gets the light, that portion gets illuminated. Illuminated means that portion is in lighted area. Whereas in this picture, the left hand side portion that you see is in the darker area where the sun rays do not reach the earth on the other side. I'm talking of this side. This side gets the circle of illumination. This is in darkness. Is this much clear to each one of you? Please respond.
Yes,
Please.
ma'am. Yes, ma'am.
Thank you. Thank you. God bless you all. You all encourage me when you respond to me. Now we talk of effects of inclined axis. Now before we go on, let me tell you, axis, this imaginary line is the axis. Okay, this imaginary line that you see is an axis. This is an axis, this vertical line, this slightly inclined line. This is not perpendicular, this is not at 90 degrees, it is slightly tilted. And the angle which it is making, at how much degree is it inclined? It is 66.5 degrees inclined. Okay. So now let us talk of the effects of inclined axis. Now this axis is inclined, that means it is slightly tilted. Let us see what happens because of this. Varying length of day and night. Now the length of day and night, they differ because of this inclined axis. Let us see how. The inclination of the Earth's axis has important consequences. Because of this inclination, each of the poles is presented alternatively to the direct rays of the sun, which causes differences in the length of the day and night over the globe. When it is summer in the northern hemisphere, the North Pole is tilted towards the sun. It means the larger part of the northern hemisphere receives sunlight, which results in longer days and shorter nights in the northern hemisphere. It is reversed in the southern hemisphere during this time. Now, please look at this diagram. Can you all see this diagram? It is very clearly given. Now, supposing this is the sun.
Yes.
Now, we all know that the Earth's axis is slightly tilted. थोड़ी सी tilted है. So, if you see, North Pole is more towards the sun, Southern Pole is away from the sun. Can you see this picture? Can you all?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. So now when you see this picture, you will see that the North Pole is getting more sunlight. Okay. It is getting more sunlight. So here days would be longer, whereas this portion is away. Can you see the illuminated lighter blue and darker blue? So this is the illuminated side. This is the side which is facing the sun. So here the illuminated side, northern pole towards it, will be having summers in the northern hemisphere. Since this is the southern, can you hear me?
Yes, ma'am.
So now see here, as the earth from here reaches this side, the axis is again same, is tilted. Now this time, if it is tilted, that means northern portion is away from the sun, the northern pole is away from the sun, and the southern portion, the southern pole is towards the sun. Can you see this? Can you see this? If this is the pole axis, the northern pole is away from the sun. It is away. The southern pole is towards the sun. So this is causing summers in the southern hemisphere, winters in the northern hemisphere. Okay? Did you get till here? So because of the tilted axis, we get to have different seasons. We get to have different rays falling on the earth's surface. Okay? Now, let us do this. Now, try to understand days and nights are caused with the help of an activity. Now, you just go through it, I'm telling you. Take a globe and a lamp and keep both in a line on table. Okay? Now, light the lamp. The glow of the lamp will illuminate the side of the globe which faces the lamp, and that represents day, and the other side of the globe remains dark, representing night. Is this much clear? Next, make a point A in the dark portion of the globe and rotate it on its axis from west to east through 90 degrees. Okay. Now, point A will turn and first get diffused light, which we notice before sunrise. This is called dawn. Now, the early sunrise as the earth is rotating, okay, is called the dawn. Then we talk of move the globe further and you will notice that now point A has sunrise. On further rotation, point A will face the lamp and at one stage there would be shadows. This is noon time at point A. On further rotation of the globe, we will notice darkness at point A. This is called sunset. At that time, it is not completely dark, but there is some diffused light which is called the dusk or twilight. Okay, so that means the evening time just before the night and just before the evening is about to end is called dusk. Okay, the name is called dusk or twilight. Now when A reaches exactly the opposite side of the lamp, it is midnight. So I hope this activity, if you do, it will make you more and more clear. When the south pole is inclined towards the sun, the larger part of the southern hemisphere receives sunlight, which causes longer days and shorter nights in the southern hemisphere. It is reversed in the northern hemisphere during this time. On the equator, the days and nights are equal, which is of 12 hours each. If the axis of rotation were perpendicular to the plane of the Earth's orbit, then every place on the Earth would have 12 hours day and 12 hours night throughout the year, and there would be no seasons. So now they are telling you, if the Earth's axis would have not been tilted, see this one, I'll show you. See this diagram. If the Earth's axis should not have been little tilted, if it would have been straight like this, okay, if Earth's axis would not have been tilted, now right now it is tilted, had it been straight, then all the portions in the entire Earth would have 12 hours day and 12 hours night. But since it is slightly inclined, so the side which is facing the sun more. Now in this case, you can see the northern pole is tilted more. This pole is tilted more towards the sunlight. South pole is tilted away from sunlight. So that means this portion will have longer days. This will have summers. So northern hemisphere will have summers. Southern hemisphere will have winters. They will have shorter days. These will have longer days. This will have shorter days. Northern hemisphere will have longer days. Southern hemisphere will have shorter days. Northern hemisphere will have shorter nights. Southern hemisphere will have longer nights. Now once the earth rotates and reaches the other side from here till here, now you see that the axis is away from the sun. The northern pole is away, southern pole is towards the earth. In that case, the southern hemisphere will have summers, northern will have winters. Now once they will have winters, that means northern hemisphere will have shorter days, southern hemisphere will have longer days. I repeat, northern hemisphere will have shorter days, southern hemisphere will have longer days. Northern hemisphere will have longer nights, southern hemisphere will have shorter nights. So how will you say? When the northern pole is tilted away from the sun, the northern hemisphere, upper side, will have winters. They will have shorter days and longer nights. In the southern hemisphere, they will have summers with longer days and shorter nights. Let's go back to this one. In this, the northern pole is towards the sun, southern pole is away from the sun. In that case, the northern hemisphere will have summers, southern hemisphere will have winters. Now the northern hemisphere will have longer days, shorter nights. Southern hemisphere will have shorter days, longer nights. Is this much clear to each one? We will stop till here. We'll begin the next heading next time. Is this much clear to each one of you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Can you all see me?
No, ma'am, we can see the back table.
लो बैक टेबल देख रहे हो चलो मुझे भी देख लो. Can you see me now?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Good. So
Yes, ma'am.
now your work is please take the diagrams that I want you to draw. I want you to draw this diagram, Earth's orbit. I want you to draw this diagram, inclination of the Earth's axis. I want you to draw this diagram, circle of illumination. I want you to draw this diagram, seasons. Okay. I want you to draw, that's it. That's it. So 1, 2, 3, 4 diagrams you have to draw. Is this much clear to each one of you?
Yes, ma'am. Yes, ma'am. And
Can you see me?
Ma'am, can you tell please?
ma'am, we have to write important terms also.
Yes, every time you have to write important terms.
Okay, ma'am. Thank you.
Ma'am, our copies will come on 6C. No?
You have to come and submit your copies in 6C, my class. I have arranged a table and there you will come and you will make
Okay, ma'am.
my class.
And ma'am, excuse me, ma'am.
Yes.
Ma'am, my parents work in medical college, so they did not get time to submit my copy.
So, child, it is totally on you. See, I have arranged it. I have arranged this. You can keep your copies here. Clear? This is the class.
So ma'am, I can submit on Wednesday.
Next Tuesday. Faiza, stop the recording, please. Stop the recording.